The dark expanse of space is about to get a lot more crowded. Right now, 3 robotic pioneers are charting their course to the moon, each carrying humanity's ambitions and scientific dreams on their mechanical shoulders. In a historic moment that's unfolding as we speak, Firefly's Blue Ghost has already reached lunar orbit. Just hours from now, this technological marvel will attempt what few have accomplished before, a controlled landing on the moon's surface. The countdown has begun, T-minus 4 days until touchdown. Meanwhile, SpaceX has just launched another lunar contender into the void. Yesterday's sunset at Kennedy Space Center provided the perfect backdrop as intuitive machines Nova-C lander named Athena thundered skyward atop a Falcon 9 rocket, beginning its swift 10-day journey to the lunar South Pole. And quietly following behind them, both is Japan's Resilience, taking the scenic route but carrying its own precious cargo of innovation and hope. 3 missions, 3 different approaches, 1 shared destination. This isn't just about planting flags anymore. It's about establishing the foundations for humanity's return to the moon, this time to stay. From testing the first navigation systems to drilling for ice that could sustain future astronauts, these robotic pathfinders are writing the opening chapters of our next great adventure. Welcome to the Elon Musk 24-hour channel. Let's dive right in. The Moon Rush. 3 robotic explorers racing to lunar glory. Blue Ghost, the Pathfinder. Blue Ghost hovers silently in lunar orbit now, its cameras capturing views of the moon that no human eye has ever directly witnessed. After taking the longer route to our celestial neighbor, this robotic explorer is about to make history as it prepares for one of the most challenging maneuvers in space exploration, a soft landing on the lunar surface. 4 days. That's all that remains before Blue Ghost attempts to touch down in Mare Crisium, the Sea of Crises, a fitting name for a mission that has overcome countless technical challenges. The Firefly team monitoring the spacecraft from Earth can barely contain their excitement mixed with the inevitable tension that comes with such a high-stakes operation. What makes Blue Ghost so special isn't just its destination, but the journey it's taken to get there. Unlike its competitors racing to the moon on direct trajectories, Blue Ghost took a more methodical approach, a longer, more elliptical path that gave Firefly's engineers precious time to fine-tune every aspect of the spacecraft's performance. The latest moon footage captured by Firefly's Blue Ghost lander is completely surreal, shares Joseph Marlin, Deputy Chief Engineer for Blue Ghost. His voice carries the weight of years of preparation. Of course, we had an idea of how the imagery would look, but seeing the real-life footage of the moon's craters and boulders from our very own spacecraft is such an inspiration and really hits home how close we are to our final destination after all the hard work we've put into this mission. That patience has already paid dividends. Just days ago, Blue Ghost's cameras captured something truly remarkable: the Earth rising and setting behind the moon's cratered horizon. These aren't just beautiful images. They're crucial calibration tools helping ensure the spacecraft's navigation systems are primed for the landing attempt. But perhaps Blue Ghost's most impressive achievement to date happened quietly, with no visual spectacle. One of its scientific instruments, the Lunar GNSS Receiver Experiment, LUGRE, successfully locked onto and tracked global navigation satellite system signals from a distance of 246,000 miles. The first time this has ever been accomplished in lunar orbit. Why does this matter? Think about how you navigate on Earth using GPS on your phone. Now imagine extending that same capability to lunar explorers, human or robotic. This technology demonstration brings us one step closer to creating a lunar positioning system that could one day guide astronauts across the lunar landscape as easily as Google Maps guides you to the nearest coffee shop. The LUGRE payload, a collaboration between NASA and the Italian Space Agency, represents the kind of international partnership that defines modern space exploration. It's not a competition between nations anymore. It's a collaborative effort to push the boundaries of what's possible. This sophisticated piece of equipment combines a high-gain antenna optimized for specific satellite frequencies, a front-end assembly with a low-noise amplifier, 2 GNSS receivers in a redundant configuration, and connecting coaxial RF cables. Together, these components allow the system to detect the incredibly faint signals from Earth's navigation satellites, signals that were never designed to be picked up from such vast distances. Blue Ghost isn't traveling light either. The lander carries 10 NASA payloads, all reported to be in excellent condition as the spacecraft approaches its destination. Among them is the Lexi telescope, developed by NASA, Boston University, and Johns Hopkins University. The instrument has been operating several hours each day, running through checkouts and initial commissioning procedures to ensure it will be ready to capture detailed images once on the lunar surface. As Blue Ghost prepares for its final descent, the team at Firefly has mapped out each critical phase of the landing sequence. First will come a 19-second descent orbit insertion burn at the 100-kilometer Paraloon point, the closest approach in its current orbit. This will begin the lander's gradual descent toward the surface. During the final hour of descent, Blue Ghost will rely on vision-based terrain, relative navigation, and hazard avoidance systems, essentially the spacecraft's eyes, to assess its position and detect potential landing hazards like craters, slopes, and rocks. The system will then select the safest landing target within the designated zone. Throughout this process, Blue Ghost's 8 reaction control system thrusters, aptly named Spectre, will fire precisely as needed. Designed and built in-house by Firefly, these thrusters generate a combined 1,600 newtons of thrust, allowing for precise orientation control and throttle adjustments to ensure a gentle touchdown. If all goes according to plan, Blue Ghost will settle onto the lunar surface in Mare Crisium on March 2nd, beginning a 14-day primary mission, one full lunar day. The scientific agenda is packed. Not only will the lander operate its various instruments to study the moon, but on March 14th, it will capture high-definition imagery of a total solar eclipse as Earth passes between the sun and the moon. 2 days later, Blue Ghost will record the lunar sunset, gathering valuable data on how solar forces cause lunar dust to levitate, creating the mysterious lunar horizon glow first observed by Apollo 17 astronaut Eugene Cernan. Even after the sun sets, Blue Ghost will continue operating for several hours into the harsh lunar night, pushing the limits of its design. This mission represents more than just technological achievement. It's the beginning of a new era in lunar exploration. Blue Ghost is part of NASA's Commercial Lunar Payload Services (CLPS) initiative, a program that mirrors the successful commercial cargo and crew services now routinely flying to the International Space Station. Instead of NASA building and operating its own lunar landers, the agency is contracting with American companies to deliver science and technology payloads to the moon, leveraging private sector innovation to reduce costs and accelerate progress. Athena, the sprinter. While Blue Ghost takes the methodical approach, another lunar lander is racing toward the same destination at breakneck speed. Yesterday's sunset at Kennedy Space Center was briefly outshined by the brilliant flames of a SpaceX Falcon 9 rocket lifting off, carrying Intuitive Machines' Nova C lander, named Athena, toward the moon. Athena stands in stark contrast to Blue Ghost both in design and mission approach. The 14-foot hexagonal cylinder, perched on 6 landing legs, resembles a mechanical insect ready to alight on an alien landscape. But what truly sets Athena apart is its speed. The lander will reach the moon in just 10 days despite launching a month after Blue Ghost. This rapid transit isn't just for show. Athena uses cryogenic propellants, supercooled liquid oxygen and methane, that would gradually boil away during a longer journey. The direct trajectory is necessary to ensure the lander has enough fuel remaining for its critical landing maneuvers. Athena is headed for the Malapert Plateau near the lunar South Pole, one of the most intriguing and challenging landing sites attempted in the modern era of lunar exploration. This region is believed to contain water ice and other volatile resources that could prove invaluable for future human missions. For this second mission, Intuitive Machines hasn't just updated its lander design, it's expanded its vision beyond simply reaching the lunar surface. One of Athena's most innovative payloads is the MicroNova Hopper, a 29-inch, 77-pound rocket-propelled drone designed to explore areas inaccessible to conventional rovers. Named in honor of computer science pioneer Grace Hopper, this diminutive flying machine will measure surface temperatures and assess water distribution using instruments provided by Hungarian and German research teams. Though built with a potential range of 15 meters, for this demonstration mission, the hopper will perform 5 shorter parabolic hops and level flights, including a journey into a permanently shadowed crater, a region that has never been directly exposed to sunlight. The scientific objectives of the Athena mission focus heavily on understanding lunar resources. NASA's Polar Resources Ice Mining Experiment 1, Prime 1, will deploy a meter-long drill and mass spectrometer to search for and analyze subsurface resources. The experiment will measure drilling forces and temperature, providing crucial data for future resource extraction efforts. Working alongside Prime 1 is Blue Origin's Honeybee Robotics Regolith and ice drill for exploring new terrain, Trident, which will bore 3 feet into the lunar surface. The drill will bring regolith samples up where a spectrometer will analyze the composition of volatile gases released from the material, potentially confirming the presence of water ice or other valuable resources. But Athena's payloads aren't limited to drilling equipment. The lander also carries a laser retroreflector array from NASA that will provide a precise reference point for future lunar navigation systems. A lunar surface communication system from Nokia Bell Labs that could form the foundation of the moon's first communications network, and a Japanese rover called Yoki that will test mobility systems on the challenging lunar terrain. Intuitive Machine's rapid approach to lunar exploration represents a different philosophy than Firefly's more measured pace. Both have merit and both face unique challenges. As we track these missions in the coming days, we'll gain valuable insights into which approach might best serve future lunar exploration efforts. Resilience, the comeback story. While Blue Ghost and Athena race toward their lunar destinations, a third contender is taking a longer, more circuitous route. Japan's iSpace Resilience lunar lander, also part of NASA's Commercial Lunar Payload Services program, is pursuing a different strategy altogether. On February 15, 2025, iSpace announced that Resilience had successfully completed a flyby of the moon, passing within approximately 8,400 kilometers of the lunar surface. This marked a historic first for a Japanese private commercial lunar lander, but it wasn't the end of Resilience's journey, merely a checkpoint. Rather than immediately entering lunar orbit, Resilience is now on a trajectory into deep space, where it will perform a series of orbital maneuvers that will eventually bring it back to the moon for a lunar orbit insertion attempt. While the exact date remains to be determined, iSpace expects this critical maneuver to occur in early May. For iSpace, this mission carries emotional significance beyond its scientific objectives. In April 2023, the company's first lunar landing attempt ended in heartbreak when its lander crashed due to a malfunction in the altitude recognition system, which incorrectly interpreted the spacecraft's position above the lunar surface. This will be a new challenge for us as a company that has experienced the frustration of failure, said iSpace CEO Takeshi Hakamada during a news conference. His words carry the weight of that previous disappointment, but also determination. iSpace understands the importance of learning from it and trying again. We aim to achieve a successful moon landing and deliver excitement to the world. If successful, iSpace will become the first private company from Asia to successfully land on the lunar surface, a milestone that would signify the growing global nature of space exploration in the 21st century. The Resilience lunar lander carries a micro-rover named Tenacious, developed by iSpace's European subsidiary. Measuring just 54 centimeters in length, Tenacious is designed to collect lunar regolith soil, which the company plans to sell to NASA, part of an emerging commercial market for lunar resources. Beyond the rover, Resilience showcases remarkable international collaboration through its diverse payload manifest. The lander carries a lunar water electrolysis device from Takasago Thermal Engineering, designed to demonstrate the potential for generating oxygen from lunar resources, and a self-contained module from Ugina, intended for experiments in lunar food production. Perhaps most poignantly, Resilience also carries the Memor Disk, a collaborative project with UNESCO and the U.S. innovation platform Barrel Hand. This disk contains 275 of the world's languages, along with various cultural treasures, a time capsule of human civilization, being delivered to our nearest celestial neighbor. The different trajectories chosen by these three lunar missions, Blue Ghost's measured approach, Athena's sprint, and Resilience's long game, reflect not just different engineering solutions, but different philosophical approaches to the challenges of space exploration. Each has its advantages and risks, and the success or failure of each will help shape future mission designs. The science behind the missions. What unites these three very different lunar landers is their scientific purpose. While reaching the moon is an achievement in itself, the real value comes from the data these robotic explorers will gather once they arrive. Blue Ghost's landing site in Mare Crisium, the Sea of Crises, offers a unique window into the moon's volcanic past. This vast basin, visible from Earth as a dark patch on the northeastern part of the moon's near side, was formed by an ancient asteroid impact and later filled with dark volcanic basalt. By studying samples from this region, scientists hope to better understand the moon's geological evolution and the timing of volcanic activity that shaped its surface. The Lexi telescope aboard Blue Ghost will observe the interaction between Earth's magnetosphere and the solar wind from a unique vantage point on the lunar surface. These observations could help scientists better understand how Earth's magnetic field protects our planet from harmful solar radiation, knowledge that could prove crucial for future human exploration of space. Meanwhile, Athena's landing site near the lunar South Pole presents entirely different scientific opportunities. This region experiences extreme temperatures, with permanently shadowed craters that may have trapped water ice and other volatiles deposited by comet impacts over billions of years. If confirmed, these resources could be used by future astronauts for drinking water, breathable oxygen, and rocket propellant, potentially transforming how we approach long-duration missions beyond Earth. The Prime 1 and Trident drilling experiments will provide our first direct measurements of subsurface ice in this region, while the MicroNova hopper will venture into areas too dangerous for traditional rovers, including the interior of a permanently shadowed crater where temperatures can drop to negative 400 degrees Fahrenheit, negative 240 degrees Celsius. Resilience's planned landing site in the Sea of Tranquility, not far from where Apollo 11's Eagle lander touched down in 1969, offers yet another scientific perspective. By collecting regolith samples from this historic region, the tenacious rover will help scientists compare the composition of lunar soil across different areas, building a more comprehensive understanding of the moon's surface properties. The lunar water electrolysis experiment aboard Resilience could prove particularly significant for future human exploration. If successful, it will demonstrate the feasibility of extracting oxygen from lunar regolith, a potential game-changer for life support systems on future lunar bases. Collectively, these missions represent the most diverse and sophisticated set of lunar science experiments since the Apollo era. The data they gather will not only enhance our understanding of the moon itself, but will directly inform NASA's Artemis program, which aims to return humans to the lunar surface later this decade. The landing challenge. As Blue Ghost, Athena, and eventually Resilience approach their moments of truth, it's worth considering just how difficult lunar landings really are. Statistics tell a sobering story. Historically, only about half of all attempted lunar landings have succeeded. The moon has no atmosphere to slow descending spacecraft with parachutes, meaning landers must rely entirely on rocket engines to decelerate from orbital velocity to a gentle touchdown. This propulsive landing requires precise timing and navigation. Too much thrust too early, and the lander wastes precious fuel. Too little thrust too late, and, well, the result is a new impact crater rather than a scientific outpost. Blue Ghost's landing sequence represents the culmination of years of engineering work. After its descent orbit insertion burn, the lander will gradually lower its altitude until it reaches about 30 meters above the surface. At this point, the lander will hover briefly, using its vision-based navigation systems to identify the safest spot within its landing zone. The 8 Spectre thrusters will fire continuously during this critical phase, gradually throttling down as the lander approaches the surface. In the final moments, Blue Ghost will maintain a descent rate of just 1 meter per second, about the speed of a slow elevator, until its feet make contact with lunar soil. Athena faces similar challenges but with added complexity due to its cryogenic propulsion system. Liquid oxygen and methane offer greater efficiency than the storable propellants used by Blue Ghost, but they're more challenging to manage. The propellants must be kept at extremely low temperatures, and the engine must ignite reliably after the long coast to the moon. Intuitive Machines has developed a proprietary terrain relative navigation system for Athena that uses a combination of laser rangefinders and optical cameras to build a 3D map of the landing area in real time. This allows the lander to autonomously identify and avoid hazards like boulders and steep slopes that might not be visible in orbital reconnaissance images. For resilience, the landing challenge is heightened by the psychological weight of iSpace's previous failure. The company has completely redesigned its altitude detection systems, incorporating redundant sensors and more sophisticated algorithms to ensure accurate position tracking throughout the descent. All three landers must contend with the dreaded communications delay. Radio signals take about 1.3 seconds to travel each way between Earth and the Moon, creating a 2.6-second round-trip delay. This means that by the time ground controllers receive telemetry indicating a problem, almost 3 seconds have passed, potentially too late to intervene. For this reason, the landing sequences are fully automated, with the spacecraft making their own decisions based on pre-programmed parameters and real-time sensor data. Human controllers can only watch and hope as these robotic explorers attempt to safely navigate the final miles of their journeys. The commercial lunar economy. These three missions represent more than just scientific advancement. They're the vanguard of a new commercial lunar economy. NASA's Commercial Lunar Payload Services program, modeled after the successful commercial cargo and crew programs that revolutionized access to low Earth orbit, aims to foster a competitive marketplace for lunar transportation services. Rather than NASA building and operating its own lunar landers, the agency is purchasing services from private companies like Firefly, Intuitive Machines, and iSpace. This approach leverages private sector innovation and investment, potentially reducing costs while accelerating the pace of exploration. The economic implications extend beyond just landing services. The scientific data gathered by these missions will inform future resource utilization efforts, potentially leading to commercial operations to extract water, oxygen, and other valuable materials from lunar soil. Consider the potential impact of confirming accessible water ice at the lunar South Pole. Water can be split into hydrogen and oxygen for rocket propellant, potentially enabling a fueling station on the moon for missions headed deeper into the solar system. The economic implications are enormous. The cost of lifting materials out of Earth's deep gravity well is one of the primary barriers to expanded space exploration. iSpace's plan to collect and sell lunar regolith samples represents another facet of this emerging economy. While initially serving scientific customers like NASA, such services could eventually expand to commercial clients developing technologies that utilize lunar resources. The Nokia communications network being tested on Athena could form the foundation of lunar internet services, connecting future explorers and providing bandwidth for teleoperation of robotic systems. As permanent outposts are established, reliable communications will become as essential on the moon as they are on Earth. Even the competitive nature of these missions drives innovation. With three different companies pursuing different technical approaches, the market will naturally select the most effective and efficient solutions. Successful demonstrations will attract additional investment, accelerating the development of lunar infrastructure. This virtuous cycle of innovation, commercial application, and reinvestment mirrors the development of earlier frontiers. Just as government-funded railroads and land grants gave way to thriving private economies in the American West, these initial government-supported lunar missions may be laying the groundwork for a self-sustaining lunar economy in the decades to come. Beyond the moon, the bigger picture. As Blue Ghost, Athena, and Resilience make their attempts to touch lunar soil, it's worth stepping back to consider the broader significance of this new phase of lunar exploration. We aren't returning to the moon simply to plant flags or collect rocks. We're establishing the foundation for a sustainable human presence beyond Earth. These robotic pathfinders are testing technologies and gathering data that will directly support NASA's Artemis program, which aims to land the first woman and next man on the moon's South Pole region by the end of this decade. The water ice that Athena will search for could one day quench the thirst of these astronauts. The navigation systems Blue Ghost is demonstrating could guide their surface operations. The lunar internet being tested might connect them with loved ones back on Earth. But the horizon extends even further. The moon is not the destination. It's a proving ground for the technologies and operational concepts that will eventually take humans to Mars and beyond. The propulsive landing techniques being refined by these missions will be essential for Mars landings, where the thin atmosphere provides some, but not enough deceleration for heavy spacecraft. The resource utilization experiments, extracting water, generating oxygen, testing construction materials, are directly applicable to establishing outposts on the Red Planet. Even the radiation monitoring instruments aboard these landers will provide crucial data for protecting future astronauts during long-duration missions beyond the Earth-Moon system. There's also a geopolitical dimension that cannot be ignored. While international collaboration remains a hallmark of space exploration, there's undeniable competition as well. China's ambitious lunar program has already placed landers and rovers on both the near and far sides of the moon, with plans for a research station at the lunar South Pole in the 2030s. The success or failure of these commercial missions will influence how quickly the United States and its international partners can establish a sustained presence on the lunar surface. The commercial approach being pioneered through CLPS may prove more agile and cost-effective than traditional government-led programs, potentially accelerating the timeline for human return. Perhaps most profoundly, these missions represent humanity's first tentative steps toward becoming a multiplanetary species. The technologies and operational experience gained from establishing a sustained lunar presence will inform how we approach the even greater challenge of living on Mars and beyond. The moon is no longer simply our celestial neighbor. It's becoming the gateway to the solar system. What's next? The immediate horizon. As we conclude our overview of these three remarkable lunar missions, let's look at what lies immediately ahead. Blue Ghost is now in its final preparations for landing in Mare Crisium, scheduled for March 2nd at 2:34 a.m. Central Standard Time. The Firefly team will be monitoring every aspect of the spacecraft's health as it prepares for the most challenging phase of its mission. If successful, Blue Ghost will begin deploying its suite of scientific instruments, including the LEXE telescope and the LUGRE navigation experiment. The lander is designed to operate for one full lunar day, approximately 14 Earth days, with the possibility of limited operations extending into the frigid lunar night. Meanwhile, Athena is racing along its direct trajectory to the moon, with landing anticipated at the Malapert Plateau near the lunar South Pole. If all goes as planned, shortly after landing, the MicroNova hopper will conduct its series of short flights, including the historic venture into a permanently shadowed crater. Resilience continues its more measured journey, with several months of transit time ahead before its planned May arrival at the moon. The iSpace team will use this time to thoroughly test all systems and refine their landing procedures, determined to avoid the fate of their previous mission. Each of these missions carries not just scientific instruments and technological demonstrations, but the hopes and aspirations of their teams. Engineers, scientists, and visionaries who have dedicated years of their lives to making these robotic lunar explorers a reality. The stakes are high, both scientifically and commercially. Successful landings will validate the CLPS model and accelerate NASA's plans for human return to the moon. Failures would be setbacks, certainly, but not the end of the road. Space exploration has always required persistence in the face of adversity. As we track these missions in the coming days and weeks, we're witnessing the beginning of a new chapter in lunar exploration, one where commercial innovation, international collaboration, and scientific discovery combine to extend human presence beyond our home planet. The moon's silent witness to human history for billions of years is about to receive its next visitors from Earth. NASA is no longer alone in its quest for space exploration. These private landers represent not just the potential for individual companies to reach the moon, but symbolize a united front of those sharing a common goal, sending humans to worlds we've never explored before, and this time, to stay. As these three mechanical ambassadors make their final approach to the lunar surface, we're witnessing history unfold in real time. This isn't just about technology or science. It's about humanity writing its next chapter among the stars. Blue Ghost, Athena, and Resilience represent something profound. Our return to the moon isn't a fleeting visit this time, but the beginning of a permanent human presence beyond Earth. From the navigation systems being tested today to the water ice being hunted beneath the lunar regolith, each discovery builds the foundation for our multiplanetary future. We'll be following these missions closely in the coming days, bringing you live updates as they happen. Will all 3 landers succeed in their missions? The next chapter of lunar exploration is being written right now. If you want to stay at the cutting edge of space exploration, hit that subscribe button and join our community of space enthusiasts. Drop a comment below telling us which mission you're most excited about, and don't forget to share this video with anyone who looks up at the night sky with wonder. This is Elon Musk 24 Hours, your direct connection to humanity's greatest adventure. Until next time, keep watching the stars. They're getting closer every day.